Okay, this section is about deriving a sum formula. It says, the whole point of this section is to illustrate how to read a textbook. And so what I normally do is I look over older textbooks that were used in the United States. One of the books I'm looking at it right now, it's not a long book. It's only, let me see, I don't know, it's under 60 pages long, and it's called Summations of Infinitely Small Quantities. It's a text that was used as supplementary material for high school students taking algebra and trigonometry. All right. So what I'm going to say is that, traditionally students would be given a textbook and they would be expected to read the textbook. Now, a lot of times people, when reading a textbook, what they're doing is that's all they're doing is reading it. No comprehension was being said, but they're reading it. And even like, nowadays people aren't reading books anymore. I mean, it's kind of sad that books, which is really the foundation of an education, has become secondary. I mean, you see students graduating from high school that have actually never read a book, which is remarkable, right? And it's certainly the other alarming thing is that students will often go into STEM areas saying the reason they're going into STEM areas is they don't like to read. And that's, again, unfortunate. I want to tell you, though, that most people that are successful, I should say most people, I have no idea, but the people that I know are successful are readers. All right. What I mean by readers is they've actually studied material by reading about it. And someone says, well, I can read. Why don't I just read and I'll become educated? It's more than that. It's paper and pencil along with your reading. All right. So I'm going to just simply say that, it's not the only way to learn, but it's fundamentally the most important way to learn. All right. So again, what I'm looking at, I ordered this book. It's called Summation of Infinitely Small Series. I looked through the book. They derive some sum formulas. One of the sum formulas they derive is one we really don't discuss anymore, but it's an important one. All right. So we're going to go through this over here. And certainly when I'm going through it, my indication to you is what you should be doing when you're reading this. Right. So it's really not so much saying, let me read this to you. It's what you should be doing when you're reading this. All right. So I'll read through it and I'll tell you what I would do if I were reading this and I were a student reading this. Exactly what I would be doing. All right. So I'm going to go to the whiteboard. I'll read through this. It's not long, but we'll get through it. All right. So let me do another share with you. I'm going to go to my whiteboard. Okay. So again, if I were reading this over here, one thing I would make sure of, do I understand what I'm reading? And, I realize some students use highlighters when they're reading. There's nothing wrong with that. I don't think that really adds much to it. But reading it says we desire to find a formula for. So I know what they want to do. In this whole section, this is what they want to do. This is their whole intent of this section over here. They want to find a formula. Now, what does that mean? If you remember, like when you took pre-calculus, they found formulas for things like this, like 1 plus 2 plus 3 plus 4 plus yada, 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 all at the end. They found a formula for that. The formula they found was n plus 1 over 2. And that's what's known as the sum of the integers. Right. They also did a formula for, some of the integers that were being squared or cubed or to the fourth power or the fifth power, where they do that basically in pre-calc at Essex, by the way. Normally it's done in what's known as algebra 2. All right. And then, of course, as you go through those sum formulas, they derive them, they prove them, and they use them. And we have used those. All right. So the intent of this over here is to derive a formula for this over here. Maybe it's easy. It's possible that's like an easy formula for this easy. It's unlikely, though. It doesn't look easy. So my claim is it's doable, though. They wouldn't ask you to find a formula unless it's doable. All right. So what we need to do is remind you of certain things you've learned in pre-calculus. So I'm going to say that these things should be well known from pre-calculus. And what are they? They're the sum formulas. So you did the sum of A. Whoops, sorry about that. You did the sum of A plus B. I'm sorry, you did the sum of sine of A plus B. You did the sine of a difference, A minus B, the cosine of a sum, and the cosine of a difference. And these were all derived in math 120. Now, again, I'm not saying you took 120 at Essex County College, but it's basically the domain of pre-calculus. And these all should be familiar to you. All right. Now, maybe the derivations aren't familiar. Maybe you have to go back and look at your notes or get a textbook and read it. That's fine. But they should be familiar. It isn't like a foreign thing to you. All right. So what I'm doing over here, I want to point out what I'm doing over here. I'm selecting two of them. Whoops, I did it again, didn't I? I'm going to select two of them. These two here. And what I want to do, selecting two of those guys, I want to write them down. So this cosine of A minus B, let me point out where that is right here. I'm going to write that down. Right, so I wrote that down. And they want the cosine of A plus B. That's right over here. And they write that down. All right, again, I'm reading this. Now, of course, if you took those two and you combined those two, you should end up with that. Now, let me just go through that with you. So if you're looking at, what do I notice over here? Well, I notice just looking at it that these two terms would disappear. And what do you get? You would get sine, I'll write this down for you. You would get sine of B, sine of A. Now, minus a minus, right, would be plus sine of B, sine of A. So what I know about those, they're like terms, add them together, and what do you get? Well, what they said you'd get. You'd get this over here. Now, they claim this is important. All right, now, certainly, if you think back to what you learned in Math 120, they might have written this differently in Math 120, and I'll write that down for you. They might have wrote down product to sum formulas, right, this over here. They might have written it down this way over here in Math 120. And I'll go through that with you. And that's going to be, looking at it, cosine A minus B minus cosine A plus B. Again, if you're wondering where this is coming from, all I'm doing is looking at this. I'm sorry, I didn't mean to divide by 2. I'm sorry, I'm going a little too fast there. Let me get my eraser out. Put that down for you again. I'm looking at this, and I'm looking at this, and all I'm doing is copying it down. So I'm going to break down what they did in Math 120 or pre-calculus. Right, so let me write that down for you. Trigonometry in high school if you took it. So let's take a look. I'm going to write that down for you now. So they would write down sine, probably they'd write down B, sine A. This can be commuted around, by the way, is equal to cosine A minus B minus cosine A plus B over 2. Now, here's the problem for a lot of students. What they were done, the teachers, you know, Mason said, yeah, really, they almost simply say, oh, this needs to be memorized. But I don't really think so. Like when I teach pre-calculus, what I tell them is these need to be understood. And from these 4, you can write a bunch of other ones down, like half angle identities, double angle identities, product to sum to product. A bunch of identities can be written out from those 4. So it's good to know the connection between them, not to memorize them. All right. Okay. So the next thing I want to point out, you know, just reading this, I'm just reading through the notes over here. It says, you know, and yeah, I'm just reading it. That's all I'm doing. It says, we'll eventually use this product to difference formula to find a simpler form of S. So again, our goal still hasn't changed. We're trying to find a simpler form of S. But now what do they tell you to do? They tell you to multiply the equation for S by 2 sine theta over 2. Well, let's write that down. So they got this expansion of S written down, and all they do is they multiply both sides of the equation by 2 sine theta over 2. So what does that mean? Every term is being multiplied by that, every single term. All right. Now, someone says that's making it really difficult for me. Why would you do that? I often question that, why people do things. And I'll tell you why they do things. They see things. How do they see things? By constantly working on something. If you constantly work on something, you're going to see something. Let's go to the next page and see what they've seen. All right. So I'm going to point out what they're seeing over here is they're looking at this thing over here, and they're looking at this, right? They're looking at it, and they're seeing this. All right, let's go through that. All right, so where's that coming from? And I want to point out where it's coming from is the formula we've given you. I'm going to go back over here, back to the other page, and I want to just simply tell you what we're looking for. We're seeing something, the cosine of a minus b minus cosine a plus b. I'll write this down for you. Whoops. Again, this is what they're saying. Is equal to 2 sine b sine a. So what I'm telling you over here is they're seeing this as being like this. All right. Now, what would the b be then? I'll put this over here. 2 sine theta over 2 times sine over the AB theta. All right, let's write this over here. Cosine A minus, whoops, not A, what's going to be? Give me a second to erase. No, just go backwards. So what's A? A is theta, right? So theta, what's B? Theta over 2 minus cosine theta plus theta over 2. So they wrote the first term down that way. Then they take the second term and do the same thing. Take the third term, do the same thing. And they would keep doing this until they get to the end. All right, so keep this in mind, that we're just taking each term to this form and writing this form down. Let's go to the next page, look at that, right? Now I'm seeing that, right? So I'm seeing each one separately. So this one here, I see they wrote this over here. This one here, I see they wrote it as this one over here. This one here, I see they wrote this down over here. Now someone could say, I wonder what this means. This means that it's predictable. That we can keep going on and on and on. All right, like the next term would be 2 sine theta over 2 times the sine of 4 theta. Well, you know what I did? I kind of said, yeah, it is predictable. Write this down, right? So I'm going to say over here is, this is something that needs to be carefully looked at. Carefully looked at. But you'd eventually, it's predictable, get to the end of it. Right? Eventually get to the end. Now, what would the end be? Well, looking at it, I'm at n theta now, so it's going to be n theta minus theta over 2 for the, cosine of that, minus cosine n theta plus theta over 2. Right? Just like we have written in each term. And here comes the big problem. Someone says, you just made this thing so much more complicated. I can't go there now. You can. I'll tell you why. This is what's known as a telescoping series. Let me outline that, where that is over here. Now, what I mean by that is, if you look at this over here, and I'm going to outline this for you, that this guy here kind of matches this one over here. All right, let me show you why that is. Minus cosine, what's theta plus theta over 2? That would be 3 theta over 2. I just did this one right here. What's this guy over here? Well, that would be plus cosine, 2 theta minus theta over 2 is 3 theta over 2. So these guys here cancel off. I hope you realize these guys also cancel off. I hope you realize these guys would cancel off. I hope you realize that whatever here, its opposite would be over there, so forth and so on. Here comes trouble. They say it's predictable. And what does that mean? There's something before this. So what is this thing going to lead to? It leads to something pretty simple. I'm going to write that down over here. So this whole thing leads to that the 2 sine theta over 2s, that's the left side, would equal something really simple. What does it equal? Cosine theta minus theta over 2 minus cosine n theta plus theta over 2. All right. Let me tell you what this is in the notes. This is right here. All right. So 2 sine theta over 2 times s is equal to cosine theta minus theta over 2 minus a cosine n theta over 2. Now, by the way, you might say, what just happened over there? A tremendous number of terms have disappeared. And that's good news. Now, what do? Well, I think this is pretty easy to follow. I solve for s. How do you do that? You would divide both sides by 2 sine theta over 2. So I'm going to say this was easy to get. We got a formula now for s. All right. Now, they go on to say that they want a simpler formula. And you might say, why are they doing that? Well, someone needs something. We don't know what they need yet, but they need something different than this. And we'll get to where that needs going to be met. All right, so what are we going to do over here? We still need to simplify. We'll derive another formula to rewrite the difference as a product. Now, what difference? This difference. They want to write this difference as a product. All right, so what did they do? They went back to those 4 formulas that they said were really important to remember from Math 121. The cosine of A minus B, what's that going to be? Cosine A cosine B plus sine A sine B. And they're going to subtract away the cosine of A plus B. All right. Now, if you do that, what happens? Well, cosine A cosine B disappears. And what are you left off with? 2 sine A sine B. Like deja vu all over again. All right, now what do? Well, they're looking at this. I want to point out what they're looking at. I'm going to circle it. They're looking at this, and they're looking at this. Again, we got the cosine of that, right? So what do they say? They say, okay, let theta over 2 equal A minus B. And then they go on to say, and then let this thing over here equal A plus B. Let me write that down. So n theta over 2 is A plus B. Okay, let me write this on the side for you. So they said theta over 2 equals A minus B. And they went on to say n theta plus theta over 2 equals A plus B. All right. So what do you get over there? Well, you know what? I'm going to add them together. And what do you get? N theta. Well, theta over 2 plus theta over 2 is just a theta. And what do I get? I get 2A. So I now know what A is. And what's A? A is n theta plus theta over 2. Let me show you where this is in the notes. And I said A is equal to n theta plus theta over 2. Well, that's done. Let's do the other one. I'm looking at this, and I want to move forward. And what I'm going to do now, I'm going to subtract the 2. So I'm going to take n theta over 2 minus that other equation. So what do you get? N theta, right? So I'm taking this, and I'm subtracting this away. Just like you learn in Math 100, just subtracting. You get n theta. Well, what do you get? 2b now. Well, that was easy. B turns out to be n theta over 2. Let me go back to the notes and show you where that is. That's right over here. So I plug it in. All right, so what am I doing? I'm taking this top part. I'm taking this whole top part, and I'm plugging in that information now. All right, that's all I'm doing. All right, using this formula. All right, it takes time and effort. It does. So I'm going to say cosine theta over 2 minus cosine n theta over 2. Well, remember what I did. I said A minus B was this. And I said A plus B was this. All right, so this is the A minus B. And what goes over there? This is the A plus B. Well, we'll go to the other side. Well, whatever the A is. Did we do A? Yep, it's right over here. That's the A. And what's this guy over here? This is the B. right? So what we do is we take this and we plug it in up here. We go to the next page, show where that's written down. That's right over here. I point this out to you, all right? We just pop it in there. Then what we do, well, I guess the only thing that really cancels off there is the 2. Okay. So I got S now equaling this. All right. What is this thing? That really complicated sum we had at the beginning, which has n terms in it. That's a lot of terms to write down. This here, 1 term. That's gold standard. Get me 1 term from all those terms. Just like if you remember, the first sum form you introduced in Math 120 was this: 1 plus 2 plus 3 plus yada, 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 up to n, had n terms in it. And they said, oh no, you can write this as singly 1 term. And that's it. 1 term. That's what we just accomplished. We got S, which has n terms in it, written down as 1 term. It might be a complicated term, but it's nonetheless it's a term. So I'm going to say at the very end of this, they say we have found our important result. Whoops, sorry about that. We have found our important result. So typically in a textbook, what do they do now? They put a box on it and they say, oh, this is important. This is where a lot of teachers are at the stage where they're saying this needs to be memorized. I don't think so. I don't think you need to memorize that. I think you'd understand the process. It isn't like you're looking at a textbook and you're finding out where all the boxes are and saying, I need to memorize all the boxes. No, you need to understand how they got to the box. How did they get there? How did they get there? That's where your education comes in. How did they get there? Well, we just walked you through that. Now, someone says, oh, you walked through that. I didn't do anything. You need to walk through that. You need to be able to get there. Now, what are they going to do? They're going to use it. And this is the part where you notice in the notes, when we're doing our Riemann sums, we did not do this. We did the Riemann sums. They're really simple, guys. What did we do? We did the Riemann sums for like really simple problems, like polynomials. All right. I want to do one for this guy right now. Now, someone says, you should know this. Well, I'm going to put this down. What do I know? I know 0 to pi, sine x, dx. I know the fundamental theorem of algebra now. The answer to that's minus cosine, right? And I evaluate it from 0 to pi. Fundamental theorem's nice to know. Well, what do you have here? Minus cosine of pi minus a minus, which is cosine of 0. Well, let's do our, sort of like our algebra, I guess. Like, what's the first thing going to be? Minus a minus 1, which is 1. No, that's not so bad. And then cosine of 0 is 1, and 1 plus 1 is 2. So I do know that. I know that engrosses 2. Right now, certainly, I want to go back and remind you how you did this with Riemann sums. You would draw a picture. This is going to be 0, and it's going to be pi. We would tell you to shade it in. Let me shade this in for you. And we would say, set up a sum to approximate that. And we'd say divide into n equal pieces. So if you divide into n equal pieces, what would you get? Well, let me put this down. Each partition, if I divide into n equal pieces, well, each partition has a base to it, would be if n equal partitions, right? So what do you get? Pi minus 0 over n, which is pi over n. So every base of our partition would have that thickness. And again, you'd put down a whole bunch of, rectangles here. I like to use right endpoints. So I'm going to write that down for you. And the curve over here, the function, is going to be f of x is sine x. And I'm trying to set up a sum here. And I'll write this down as a equals. Well, every partition is the same. So pi over n times. Well, what's the first right endpoint? Well, it'll be 0 plus pi over n. So it's going to be the sine of 0 plus pi over n. Well, the 0 is a nice starting number. So let's go with pi over n. Plus, what's the next one going to be? Sine. These are the heights, by the way. Well, 2 pi over n. So I'm going to write down pi over n times 2. We're moving over to the second one. Go to the third one. That's going to be pi over n times 3. Well, you know, I'm going to do this now. Yada, yada, yada. We're going to the very last one. Hope you realize what we're doing. Very last one's over here, right? There's one before that, like this over here. What's that going to be? Let's write that down. Sine. We moved over n of them, right? So it's pi over n times n. Now, you know, when I'm in class, I'm always telling you not to simplify these guys, and I don't think you should. All right. So what I'm going to do over here is I got a sum. Let's see if they got the same sum. Well, I'm seeing it. And I'll point out where I'm seeing this over here. I'm seeing this A right over here. So I just wrote down. Now what do? They use that sum formula. So what I want to do is I'm going to go over here. Remember I said this is really important? So I'm going to look at it. And they said this is really, really important. And I want to see if I see what they've got. And what do I see? I now see the theta in the problem. One, two of them, three of them, up to n of them. So all I'm going to do is plug it in. All right. So I got this number here. And then I'm going to do this sum over here. And what's that sum going to be? Sine. I'm just looking at the formula. Whatever the theta is, so that's pi. Let me see what I did here. Pi over n divided by 2. So that's pi over 2n, right? Again, I'm looking at this over here. And then plus, well, it's going to be n times, I'm sorry, n over 2 times pi over n. Well, it's pretty simple. And then I'm going to get, you know, n over 2 times theta. Get this thing over here. Again, remember, theta is pi over n. And at the bottom, what do I get? I get sine of that theta, which is pi over n divided by 2. That looks pretty simple. Then what do? They do something pretty strange. All right. And let's take a look at it, see what they've done. They wrote it differently. There's no doubt about it. So I'm going to say, you know, what they're seeing over here is, I'm definitely seeing this part. I'm seeing it. Now, by the way, I'm seeing this too. And I'll tell you where I'm seeing it. I'm seeing it right over here. All right. Now, what do I say? Well, I'm seeing this. That's this right over here. Again, the ends cancel off, right? So we get pi over 2. And I'm seeing this. And I'm seeing that right over here. What do they do over there? They just cancel it in. That's all they've done. If someone says, why would they have done that? I don't know. Let's go to the next page. The reason they've done that is they want to take a look at the limit as n goes to infinity. Well, let's do that. Let's write that down. So we realize that we've done that with polynomials. We had to know the limits. So I'm going to say A is going to be limit as n goes to infinity. You notice I have an equality now of this thing. So it's going to be 2 times, well, let's write this down, pi over 2n sine pi over 2n times the sine. Let's see if we can do this. Pi over 2n plus pi over 2 times the sine of pi over 2. Well, you know what? I got to simplify it. By the way, I don't want to confuse it over there. I got to factor some things out that are constant, because that limit looks really tough. And what do you get? Well, you certainly get 2. That's that guy over there. That's constant. And sine pi over 2 is 1, right? And we're left off with, well, you're left off with a limit now. Limit as n goes to infinity. It's going to get tough. Not really. It shouldn't be tough, right? All right, let's take a look at this. And I want to point out there's a couple limits you probably should remember. I'm going to write them down for you. You should probably remember the limit as x goes to 0 of sine x over x equals 1. A related limit to that is a limit as x goes to 0, right, of x over sine x is equal to 1. Now, where did we cover these things? When we did the squeeze theorem. Hope you remember that. All right. So what I want to do is I want to look at these limits. I want to look at this guy here and this guy here. The second guy is really easy to do. Let me point out why that is. If n goes to infinity, this term here goes to 0, so you're left with sine of pi over 2. So that limit goes to 1. Now, the other guy, it might be tough, but I'm looking at it. And what I notice about over here is, as n goes to infinity, this top goes to 0. Well, it's just like this guy, the top goes to 0. At the same rate, this guy's argument goes to 0, which is the requirement that this guy and this guy's going to be turned to 0 at the same rate. So what do you know of this over here? Its limit is also going to be 1. So what do you get over here? A, whoops, sorry about that. A is 2 times 1. First limit's 1, second limit's 1 is 2. We just show what we're supposed to show. All right, let's go to the next page and make sure they're saying that for us. Yep. I do want to claim there's footnotes over here. If you do look at the footnotes, they talk about the squeeze theorem, which I just mentioned to you. On the prior page, they did talk about the approximate area that we're doing. We're doing a right endpoint method. All right. So the intent here is I'm not asking you to memorize anything. I'm just saying that, you know, if you want to become, you know, like a participant in the STEM field, and again, when I say that, it's going to require paper, pencil, and reading and making sense out of what you're reading. That takes time. That takes effort, right? You want to put the time and effort into it if you're thinking about becoming a participant in this STEM-related career. Thank you for your attention.